All right, let's talk Bohr models. Bohr models in chemistry are really a useful tool. What they do is to help visualize atoms, and in particular, they're really good to look at the electron cloud and where the electrons are, because it turns out that the electrons is where all really the most cool chemistry ends up happening. So they're really good to visualize where electrons live. In a previous video about atomic structure, I showed you this picture. This is a Bohr model of an atom. There are many models that we can use in chemistry, but this one's just particularly interesting. And so the Bohr model that we're going to look at, is all about seeing a nucleus in the center and then these circles around it. Okay, so those circles are known as energy levels, okay? And so we are going to be sticking to elements on the periodic table. Really all we're going to talk about in this class is elements down to this guy here, argon. And you'll notice that that is 3 rows of elements. The rows are kind of broken up. Hydrogen and helium are the only one in the first row, and then this is the second row, and this is the third row. And it turns out that the row that the element is in, that you're drawing an atom of, has as many energy level circles as the number of row that it is in. So this is an element, sulfur. And if you were drawing a Bohr model, you could plan on having 3 rings around the nucleus because it's in the 3rd level here. Make sense? All right. So these energy levels that we're going to talk about. Oh, and by the way, the reason that we don't go down beyond argon is that the chemistry gets a little bit goofy as you go into the 4th level, 5th, 6th, 7th, and so on. But the same pattern holds true. Like if something was in the 6th level down here, you could expect to see 6 circles around it. We're just not going to get that far in applied chem. Okay, so in our energy levels, the first energy level, which is the closest one to the nucleus, which in a Bohr model is typically just drawn as a dark circle here, just a dot like that. That represents all the protons and neutrons. The first energy level, which is the closest one to the nucleus, only holds 2 electrons, okay? And that's why, I don't know if you noticed this in the image that I showed you earlier, but see how this first circle here only has 2 blue dots on it? That's because it's the first energy level, and you can only hold a maximum of 2 in that level. In the second energy level, you can have a maximum of 8 electrons, and in the third, you can have a maximum of 8 electrons. So let's do a little bit of math here. If we add 8 and 8, that's 16, and another 2 is 18, right? So 18 electrons in these first 3 levels. And believe it or not, that is no coincidence that our last element in our 3rd row has 18, an atomic number of 18. So there's a connection there for sure, and hopefully you'll see it here before too long. All right, so let's practice with a Bohr model. And sometimes I like to just kind of put this at the top of some stuff, like I'll just say 2, 8, and 8. And these little lines are representing, just a small portion of one of these energy levels. So this Bohr model is set up to be an atom from the 3rd level of the periodic table. So let's just pick one of these at random. How about we do sulfur, since we talked about that one? So sulfur. Remember, the number of the atomic number, 16 in this case, that is specific to the number of protons in the nucleus, but it's also specific to the number of electrons in the electron cloud. Okay, so we're going to fill 16 dots into this. We're going to assume this is sulfur, and it has 16 electrons. And so what you do is just start from the inside and work your way out, okay? So, and you just maximize your energy level and then move on to the next one. So obviously the first one, we're gonna put 2 electrons in, and that's the end of the road for that energy level. There's only 2. The next one, we can hold a maximum of 8, and these actually will go into pairs like this. And there's our 8 electrons. At this point, we've added 10 total electrons. We're trying to get to 16, so we need 6 more electrons. So that's 1, 2, 3, 4, 5, and 6. Okay, and that is the completion of a Bohr model for an atom of sulfur. All right, I hope that's easy enough. Let's do a smaller atom here. This one is going to be an element from the second row because it's got 2 circles around the nucleus. Let's just pick, let's look at boron. This is a pretty neat element. So boron's atomic number is 5. That's 5 protons and also 5 electrons. So we're going to fill 5 electrons into this guy. And again, start with the innermost level and work your way out until you've got all of your electrons. Here's the first 2, and we need 3 more to make 5, so that's 1, 2, 3, okay? And it's really, these Bohr models are really interesting because it turns out that this level here, the outermost level, is where all of the chemistry happens as atoms react with other atoms. Okay, so this is known as the valence level. Okay, so the valence level is the outermost. Okay, and the electrons that live on the valence level, they are known as valence electrons, okay? So every atom has a valence level, and it could have a different number of electrons in the valence level, but that term valence is pretty important to us. Okay, so that is how you make a Bohr model, and you will never have one that's got any more than 3 of these energy levels in it. So I think that simplifies things for us a bit. All righty, hope that helps.